So now see next example. In this one, a car accelerates from rest at a constant rate a for some time, after which it retards at constant rate b. If the total time lapse is t, evaluate the maximum velocity reached and the total distance travelled in terms of a, b and t. So now you have seen in question here, velocity is accelerating at the rate of a and then it is retarding at the rate of b. So obviously acceleration is a and retardation is b. So now this question we will be doing here by using graph. So we can take here, suppose you are taking graph like this. On x axis we take here time and on y axis we take velocity. This is 0 point here. Suppose body is accelerating to the certain time and this time interval we can take t1 and this rate of acceleration is a and this is the maximum velocity reached, we can write v max. Then it retards uniformly and reaches to this point. Here retardation we can take b and this time interval is t2, but we know it t1 plus t2, that is total time lapse, is given to us t. So we have to calculate first maximum velocity, then we have to calculate distance travelled. So now for the maximum velocity we can write, we will be using the concept of slope of the graph. So now see here, we can write simply here a is equal to v max upon t1 and here we can write b is equal to v max upon t2. This is the slope for this part, slope for this part. We can get value of t1 and t2 from here. So t1 is equal to v max upon a and t2 is equal to v max upon b. Now we will be just adding these two equations. When we add these two equations, we will be getting t1 plus t2 is equal to v max 1 upon a plus 1 upon b, and we can write here t is equal to v max a plus b upon ab. So v max is equal to maximum, v maximum, that is the maximum velocity, a b t upon a plus b. So this is the maximum velocity attained by the body in terms of a, b and t. Now we have to calculate total distance. You know, if you have got velocity time graph and you want to calculate total distance, you have to just calculate area enclosed with the time axis. So this is the area enclosed with the time axis, just a triangle. So we can write here distance s is equal to half of, this is triangle, so base is this total time lapse, that is t, and height is, this is maximum velocity. So we can write here v max. So s is equal to, just replace the value of v max from here, we will be getting a b t square divided by twice of a plus b. So this is the total distance travelled by the body in the total time lapse, that is capital T. So these are some examples related to kinematics. All these examples were based on the equations of motion, graphical method, integration process and also differentiation process. So you have done here the motion in a straight line and most of the concepts. Now we are going to do the next concept, that is the relative motion in one dimension.